Okay, so for this one, the first one here, to decide if that's a right triangle, we first have to decide what angle is going to be our candidate to be the right angle. Which is the only angle here that could be a right angle? The top left, the one between the 11 and the 60. Why? What's that? Well, because in the picture it looks like it's closer to the right angle. Not necessarily. You can't trust my pictures. But if it is a right triangle, the right angle would have to be between the two smaller sides. Remember, the longest side would have to be, if it were a right triangle again, would have to be the hypotenuse, which is across from the right angle. So that right angle is across from the longest side, the 61. If it is a right angle, we don't know that yet. So I'm going to put a question mark in it. So that would mean what side would be side C? I'm going a little bit backwards here. 61. So the 11 and 60 doesn't matter which is A and which is B. I'm just going to fill them in. And my formula, A squared plus B squared equals C squared. And I can just go ahead and fill in numbers. So A is 11, so it'll be 11 squared. B is 60, so it'll be 60 squared. And C is 61, so that's 61 squared. Well, 11 squared is 121. 60 squared is 3,600. 61 squared is 3,721. We add 121 and 3,600 to get 3,721. What's that tell us? It's a right triangle. Because those two numbers came out to be equal, that is a right triangle, and this is a right angle here. Any questions on that one? How many of you got that to work out? How many of you don't care this early in the morning? Okay. Down to the next two. The first one's relatively straightforward. I give you the right angle here and ask you to find the missing side. Now the first thing we always have to figure out is, are we looking for the hypotenuse or the leg, or one of the legs? Here, are we looking for the hypotenuse? No, the hypotenuse is the 113. That'll be our side C. So we are looking for one of the legs. Usually it's easier for me if I make the leg I'm looking for leg A, side A, and the one that I have, side B. So again, A squared plus B squared equals C squared. So it'll be X squared plus 15 squared equals 113 squared. So now X squared is just X squared. 15 squared is 225. 113 squared, I gotta punch that one in, 12,769. Then what do? We'll subtract 225. So your X squared is 12,544. And then what? The square root. It's X squared, so we have to square root it. The square root of 12,544 is 112. How many of you got X as 112? Getting a little thinner, huh? Okay, looking at this last one. How many of you got an answer for the last one? Anybody got an answer they want to share? One of the keys to dealing with geometry, and I haven't mentioned this in class yet, I wanted to see who knew it instinctively or not. One of the keys with dealing with geometry involves a a concept we went over in class yesterday, and that is parallel lines. If you can make a line parallel to another line, or parallel to the line, the length that you're trying to find, that can be very useful. In this case, this is the length I'm trying to find right here. And I can put any number of lines parallel to it that are all going to be the same length. Because of parallel, if this line's parallel to that, this angle here and here are going to be the same, and that length is going to have to be the same. Well, the one I just drew in there is not the one I'm interested in. The one that's useful would be this one right here. If I draw in that blue line parallel to y, this is a right angle just like that is. And of course, these are right angles just like that is. One of the consequences of dealing with making parallel lines like this, a lot of times we end up making rectangles. And that's also a very useful tool. That's the second very useful tool, is to create a rectangle. Because you know not only are opposite sides of a rectangle parallel to each other, but opposite sides of a rectangle are the same length. So this blue line here will be the same length as y. And this distance here is going to be how much? 14, the same as on top. Why is that useful? Well, because now it tells us that this distance here must be 4. If the whole thing's 18, 18 minus 14 gives us 4 left over. And now what we have to work with is a right triangle. Now I'm going to pause. Any questions on how I came up with that yellow triangle there? So the key to this type of problem is just seeing that triangle. So, how do I go about finding y here? Well, first of all, is y the hypotenuse or one of the legs? One of the legs. So I'm going to make it A. The other leg's B. 5 is the hypotenuse. I'm going to call that C. So I have y squared plus 4 squared equals my hypotenuse of 5 squared. Y squared will not change. 4 squared is 16. 5 squared, 25. And then subtract the 16. Y squared equals 9. And then the square root of y squared is y. The square root of 9 is 3. So the length we are looking for there is 3. Questions? See, I'm going to give you guys a related problem to work on. Now, if you guys recall, when we were asked to find the area of a triangle, we did right triangles mostly, but we also said that as long as you knew this height here, let's say we know that height is 8 inches, and the length of the base, let's say we know this base is 14 inches. We can find the area of that triangle because it's just half of whatever the area of that rectangle is. The area of that rectangle is 14 inches by 8 inches. And you just divide that by 2. Right? So that would make that area 56 inches squared. Look familiar? It's been like 4 weeks since we did that. So now scroll down to here. If I tell you that the base of that triangle is 14 inches, and I tell you that each of these sides is 24 inches. Find the area of that triangle. Tell me where to start. Okay, there it is. You cut the triangle in half down the middle here. And by doing that, you create two right triangles. The reason you're able to do that is this. In a triangle, the largest angle is always opposite the largest side. So since these two sides are equal, these two angles have to be equal. So if those two angles are equal, that means this is symmetrical. So you can cut it right down the middle. Since these two angles would have to be equal, they both have to be 90 degrees because they add up to a straight line. So what we've done is we've created a right triangle. This piece is 7 inches, half of the 14. And we can find its height. How do we find its height here? We call that A. The 7 is B and the 24 is C. A squared plus B squared equals C squared. Gives us A squared plus 7 squared equals 24 squared. A squared plus 7 squared is 49. 24 squared is 576. Then we subtract the 49. Get that A squared equals 527. And then we have to square root it. And yes, this one does not come out pretty. That sounds like it, yes. 22.956 we're going to call it. So that's the height. So that means the area of this would be the base of 14 times the height of 22.956 divided by 2 because it is a triangle, which comes out to be 160.695. And that is going to be inches squared. In my math lab, either it'll ask you to include the units, or a lot of times what it'll be is after the box where you put the number in, there'll be a little pull-down menu. You have to pull down and select inches squared or inches or feet squared or whatever. So make sure you do that or it will count those problems wrong. Any questions? How many of you saw how to divide that triangle up and got the area? We're having a bit of a slow start this morning. No problem. We'll jar it loose. Okay, well, I left you guys yesterday with an extra credit question. I have not checked my email this morning, but did anybody send me an answer to it yet that I didn't shoot down? Anybody have an answer they want to share now? So if you recall, the question was, I believe it was Pat, wasn't it? Set up hunting camp. And from hunting camp, Pat set out and walked how far south? Was it 12 miles? 12 miles due south. Then he turned and walked 7 miles due west. And at that point, our hero Pat found and This is 2 days in a row I've had successful artwork, so I don't know. Well, I call it successful. You guys might not. Close enough. Found and shot a bear. And he's trying to figure out how to get it back to the camp, and he realizes he is still exactly 12 miles from camp. And of course, the extra credit question was, what color is the bear? Somebody tried to tell me red because it's been shot and it's bleeding. Nice try, but remember, you not only have to tell me what color, but you have to tell me why. I suppose bleeding is a good excuse, but not what I was looking for. Anybody have an answer? The bear must be white. Why? Well, we're used to thinking of geometry as being on a flat surface. The only place in the world where it is possible to walk 12 miles due south and then 7 miles due west and still be 12 miles from camp would be if their camp is on the North Pole. Because once you've walked 12 miles south, no matter how far you walk straight west, you're always going to be 12 miles from camp. And of course, bears at the North Pole are white. A little bit of spherical geometry thrown in. No extra charge for that for the class. But, you know, if you have any of those people in your family that, you know, think they're smarter than everybody else, that's a great one to throw in their face. Bug them over Thanksgiving dinner, let them sit in the corner and work on it. And tends to shut them up. Actually, my favorite one that I used, I don't do much for family gatherings anymore, but I have a cousin who used to be one of those, I know everything, but a very chauvinistic type person. So the one I nailed him with was a man and his son are in a car accident. The man is killed instantly. The son is rushed to the hospital. They take him into surgery. The surgeon walks in, looks at the boy and says, I can't operate on this boy. He's my son. How is that possible? Anybody know the answer? What's that?
The wife is the surgeon.
Yeah, his mother's the surgeon. But I've had groups, I work with a lot of groups like the construction groups and stuff that are all men, and I've had groups sit here for like 45 minutes and not figure that out. I had him sitting there for like an hour and a half and not figure that one out. Okay, so back to math. We left off with the geometry and using the Pythagorean theorem to find missing parts of a triangle yesterday. So a little bit of review of our areas, since we talked a little bit about that here to start off class. If I have a rectangle that is 6 inches by 20 inches, how do I find its area? Technically, I should tell you that at least one of those is a right angle, shouldn't I? Its area is going to be length times height, length times a distance. So 20 inches times 6 inches, which is going to give us 20 times 6 is 120. What's my units? Inches times inches will be inches squared, or square inches. We've run into triangles. We had right triangles like this. How do we find the area of a right triangle like that? (18 inches times 9 inches divided by 2, because remember that triangle is only half of what we called the related rectangle. So 18 times 9 is 162, divided by 2 is 81 inches squared. Those two looking familiar? A little bit, not so much. Okay. This was like beginning of the second week, I think, or end of the second week. It was back there a ways. If we have a triangle that does not have a right angle, you'll recall that what we needed was two dimensions that are at a right angle to each other. So if I have this bottom down here, let's say that that's 20 inches, and let's say I know that this height here is 13 inches, to know if those two dimensions will work to find the area, I have to answer two questions. Question number one is, are they perpendicular? In other words, do they form a right angle with each other? In this case, the answer is yes. The second question is, do they define a rectangle? What I mean by define a rectangle is, do they define a rectangle that would contain the related rectangle that would contain this triangle? If I draw in a rectangle based on those dimensions, is one of those dimensions the length and the other one the width or the height? Yes. So they do define a rectangle. So that 20 inches and the 13 inches can be used to find the area of this triangle. So the area is going to be the 20 inches times the 13 inches divided by 2, otherwise known as 130 inches squared. What do you think? Not terrible so far? Looking at this here, that is a parallelogram. Parallelogram means opposite sides are parallel and opposite sides are equal. Do I have enough information right now to find the area of this? Do I have enough information right now to find the area of this? No, I don't. Because the dimensions I'm given are not perpendicular and they're not defining a rectangle. What I need is this dimension right here. That would be perpendicular to the 40, and it would define a rectangle because I could take this triangle here, pull it off, and fit it right in there and complete my rectangle, couldn't I? So if I knew that dimension, I could find the area. But I don't know that dimension right now. But if I were to tell you that this dimension right here were 33 inches, now am I able to find that dimension? Yes. What's this dimension here have to be? Perfect. 40 minus 33 will give us 7 inches. Now if I call this X here, or I could call it A, I suppose, because it's going to be one of my legs. B is my other leg, will be the 7, and C is the 25 is my hypotenuse. A squared plus B squared will become A squared, or X squared, plus 7 squared equals 25 squared. At this point, I'm going to trust that you guys can work that equation out to get that A equals 24. So this is 24 inches across here. Any questions? So now my area is 40 inches times 24 inches. That's the dimension that's perpendicular. Do I have to divide by 2? No, it's not a triangle. It is the full rectangle. The area I'm finding is based off of the full rectangle. So, is that 9,600 inches squared? Does that look right? What's that? Maybe not. 960, I got an extra 0? Okay. 960 inches squared. What do you think? Still not horrible? Yeah, yet? Wow, you have little faith. I'm a little hurt. Kind of them. I'm going to issue this one as a challenge problem for you. No. This problem here, with what we're given there, is it possible to find the area of that triangle? Now, I will come back to this at some point later on and solve that for you. But for right now, you can throw it in your notes, see if you can figure it out. Now, I'm not going to give you a lot of time right now to figure it out, but hopefully at this point everybody's got it copied down. So let's look at something related to it. Oh, let's see here. You ever have one of those days where your mind just shuts off and says, nope, not going to do it anymore? I'm having one of those. Every day. I haven't looked at the quiz yet. Is that an omen of bad things to come on the quiz? Or? Enough's enough. Sure. We have those days. Okay, so on this one, the bottom is 17, but I broke it up into 7 and 10 for you to make it easier. Now, we're assuming there's some sort of units like inches or feet, but just for the sake of time and space, I'm going to stop putting units on for right now. Now, I put a right angle symbol there, but I probably shouldn't, because I don't know for sure if that does break it into a right angle. To double check, what we would have to do is we would have to check from both sides to see if I do A, B, and C here, if I get a result for A, and then I do A, B, and C over here if I get the same result for A. Does that make sense? So let's do the left side here first. A squared plus 7 squared equals 25 squared. So a squared plus 49 equals 625. Subtracting 49, a squared equals 576. And then square root to get that a equals 24. So from the left side, I get a equals 24. I want you guys to do the triangle on the right side and see what you come up with for a. See if it's also 24. I'll give you a couple minutes in your notes. So from the right side, what do you get? That a squared plus 10 squared equals 26 squared. Do you come up with 24 for a? Yes. So that means we can find the area of this by doing what? Yep, that tells us those are right angles. Perfect. So 24 times 17, and then? Perfect. Divided by 2, which gives us, what, 204? And whatever units that is squared. Well, let's take a step. So far, when we've talked about areas, we've mentioned the only area we know how to find is the area of a rectangle. Every area we have found has been based off of a rectangle. We based a triangle off of its related rectangle that contains the triangle and cutting it in half. We based parallelograms off cutting one end off and making it into a rectangle. All areas involve a rectangle or a related rectangle. Now with that said, let's look at a circle. First, to review some parts of a circle, if I go from the center of the circle out to the edge, what's that called? Radius. If I have a segment that has its endpoints on the circle, does anybody know what that's called? That is called a chord. A chord that contains the center of the circle is called a diameter. The distance around a circle is called the circumference. There are some important relationships here. One is the relationship between the diameter and the radius. The diameter is equal to 2 times the radius. Or the other way around, the radius is equal to half the diameter if you prefer it that way. The circumference is equal to the diameter times a mythical constant called pi. Technically, the definition of what this little symbol, pi, is the circumference divided by the diameter. That ratio, circumference divided by the diameter, is the same for all circles. It's a constant. It's approximately 3.1415926, blah, 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 blah. We will use 3.14 for the most part in here. Now your calculators, most of your calculators have a pi key on them. For many of you, it's actually a second key. You got to hit the second or the shift. It's over on the right side, about 3 buttons down from the top, 2 or 3 buttons down from the top. You have to hit shift and then press that key. In my math lab, it'll usually tell you to use, pi equals 3.14. It'll tell you what to use for pi. If you use the pi key, sometimes the round-off errors will be off by a couple of tenths. When we do some of the calculations in class here, we'll see some of that. So make sure you pay attention to what MyMathLab tells you to use for pi. Now, if you're doing homework and you get one wrong, and you look at your answer compared to the real answer, and you're off by a couple tenths, don't worry about it. I'll give you credit for that. On a quiz, if you get one wrong because of that, send me an email, and I will go through and I'll change those grades for you. Because the pi key is technically more accurate. It's just MyMathLab wants you to do it a certain way. So the circumference of a circle is equal to the diameter times pi. Now the diameter is 2 times the radius. So another way of writing the circumference of the circle is sometimes 2 times r times pi. 2 times the radius, which is the diameter, times pi. So if I have a circle with a radius of 5 inches, how do I find my circumference? Well, we're multiplying something times pi, but what's it going to be? Yeah, the diameter, which would be how much? 2 times 5, or 10. So 31.4 inches is what we get. I'm using 3.14 for pi just for ease. Pretend that looks like a circle. With a diameter of 8 inches, how do I find the circumference? Well, 8 times pi, right? Which is going to be about 25.12. Questions? A little bit of a throwback here. How do I find the perimeter of a rectangle? Now, we use this fancy formula, perimeter is equal to 2L plus 2W, right? But back to basics. If I don't remember that formula, what do I do to find perimeter? I just add them up. Perfect. We add them up. 13 feet plus 6 feet plus 13 feet plus 6 feet, which is 38 feet of length, 38-foot perimeter. How is perimeter different from circumference? Short answer, it's not. Circumference is just the perimeter of a circle. It's just a fancy word for the perimeter of a circle. If I asked you to find the perimeter of this figure, assuming that those are right angles, how would you do it? Well, I'm just going to add it to sides. I can cut this across here. This side over here is 13 feet. I need to know this length here. I know this is going to be 8 feet across here. We mentioned those rectangles. If you can make rectangles, it's very powerful. Here's another case. I cut that across there to make a rectangle, so I know that that has to be 8 feet. Opposite sides have to be equal. Now, if I view that as being a full circle, the perimeter or circumference of that full circle would be 8 times pi, or 25.12 feet. So that makes this length from here to here how much? half of it divided by 2, 12.06 feet. So now I add up 13 feet plus 8 feet plus 13 feet plus 12.06 feet gives us 46.06 feet of perimeter. What do you think? Questions? Okay. Well, we've played with the perimeters and circumferences a bit. Let's bite off the area of a circle. Now, most of you know the formula for the area of a circle. Can anybody tell me it? Pi times what? Pi times radius squared. Pi r squared, right? Now, I said earlier that all areas that we find are based off of a rectangle. How is that based off a rectangle? It's circle, has no corners. Let me show you. I'm going to take my circle, I'm going to draw in a diameter here. It's got a radius of r, right? So that makes that diameter. 2r makes the diameter. What's the circumference of this circle? Well, I'm going to do 2 times pi times the radius. I'm doing 2 times the radius instead of the diameter times pi, right? 2 times the radius times pi instead of just the diameter. So now with that definition of the circumference, that's the whole way around here. What is the distance around half of the circle? Well, if I divided that by 2, what would happen? The 2's would cancel out, wouldn't they? That's just going to be pi times radius. So now here's what I'm going to do. I'm going to slice that half a circle into really thin pi slices, as thin as I can get them. This is actually what calculus is about, is slicing stuff into really, really thin pieces. Don't worry, that's as far into calculus as we're going to go in this class. So now I'm going to take those thin slices I got, and I'm going to fan them out. Like this. Pretend they all come to the same spot and that my artwork does not suck. There. So I fanned them out like that. Now I'm going to come to this other half circle. I'm going to cut it in equally thin pi slices. And I'm going to fan them out. And what I'm going to do is I'm going to slide them in between the teeth of this other one. And they should fit perfectly if my drawing didn't look horrible. So now over here, if I cut these thin enough, this distance across here is that distance around half the circle, pi times r, right? What's this length here? That's just the radius, right? So what I've created here is a rectangle that has a length of pi times r and a width of r. So it's pi times r, or pi times r squared. Now you don't need to derive that. You just need to know this formula, memorize that formula. Area equals pi times r squared. But it is kind of neat to see that it still comes from a rectangle. All areas, period, come from a rectangle. That is the only shape in the world that we know how to find the area of, is a rectangle. So anyway, how do we find the area of that? pi times 7 squared. Good. Now the units are going to be feet squared because the length was in feet. So pi, I'm going to put in 3.14 times 7 squared will be 153.86. Any questions on that? So in your notes, find the area of that one. I'm sensing a little bit of cynicism developing amongst the ranks here.
He didn't hear it, did you?
No. So my area is going to be pi times what? 4 squared. Where'd the 4 come from? Half of 8. The 8 is the diameter. And for area, we use the radius. So that'd be half the diameter, or 4 inches. Pi times 4 squared is going to be 50.24 inches squared. How many of you got 50.24? You used the pi key, didn't you? Yeah. Yep. If you use the pi key, that's fine. Just remember, if you're doing my math lab, you got to make sure you do what it tells you to for the pi. For pi. Anybody not sure where the 50.24 comes from? Now another little challenge problem for you. Now I'm going to tell you here that I am using 3.14 for pi. If I tell you that the circumference here is 31.4 inches, find the area. I'm going to give you a minute to think on that. Anybody get an answer for the area before I start? Not yet? 78.5 inches square. Let's see how that works out. Well, from the circumference, what can we find? We know that circumference is pi times diameter, right? So that's 31.4 is the circumference equals 3.14 is pi times the diameter. I'm going to pause there for a second. Any questions on where that came from? Just took my formula for circumference, put in my number for circumference for C, my number for pi, the 3.14. And now to solve for the diameter, I'm going to divide by 3.14. You get that 10 is my diameter. Now I don't want my diameter, I want my radius, which will be 5 inches for my area. So that'll be pi times 5 squared, or 3.14 times 25, which is 78.5 inches squared. Good job. Any questions? Well, back to this problem. Pretend I drew it better. How would I find the area of that? Well, I'm going to cut it across there, just like I did before to find the perimeter. And now I have a rectangle here. The area of that shape, that rectangle, is 13 inches by 8 inches, otherwise known as 104 inches squared. And then I have this piece up here, which is my half circle. What is the radius of that half circle? 4. Yeah, this whole distance across here would be 8, so that radius is 4 inches. So for piece 2 there, my area is pi times 4 squared, but divided by 2. Why is it divided by 2? Because it's only half a circle. So does that come to be 25.12 inches squared? I add those up to get 129.12 inches squared is my area. Now we discussed a little bit before how sometimes it's easiest to find the areas and add them together, and how sometimes it's easiest to find the areas and subtract them, and how sometimes you have to do it one way or the other. Here, the only way you could have found that area is by finding the two pieces and adding them together. There was nothing you could have subtracted off. Bless you. However, we could run into one like this. That is a quarter circle there. Doesn't look like much of a quarter circle, but it is. Let's say that's 30 feet. That's 18 feet. That's 10 feet. How would I find the area of that? Well, first of all, I'm going to cut out the piece that has the circle, the quarter circle in it. I can cut this. Now, can I add up piece 1, 2, and 3? Does that work? Say no. Why not? Well, yeah, since I can find pieces 1 and 2, but piece 3 is impossible to find. Well, not impossible. It's just really, 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 really difficult with what we know. But I could do this. Make that a complete rectangle that is 18 feet by 30 feet, which would be 540 square feet. Then subtract out, how big is the radius of this? 8 feet. 18 minus 10, that has to be 8. By the way, a little trick of finding missing dimensions, bless you. What would this dimension here have to be? 22 feet. A lot of people do that. Well, how do you know that this is 8 feet? Well, because it's a circle. The radius has to be the same no matter what direction it goes in. So if it's 8 feet here, it has to be 8 feet here. So anyway, to find that area we're going to subtract out there, it's going to be pi times 8 squared, but divided by 4, because it's 1/4 of a circle. So that is going to be, what, 50.24, I believe, square feet. Does that work out right? So now we subtract to get 489.76 square feet of area. What do you think? Not so bad? Show you another example here before I let you guys try one. Those are both half circles. This is 20 inches, and this is 10 inches. I want to find this area. Well, to find this area, I'm going to cut it like this to make a large area of 20 by 10, which is 200 inches squared. Now I have to subtract out this half circle and this half circle. But there's a little trick we can deal with. Not only can I cut pieces out, but I can also slide them back together. So if I'm cutting out those half circles, what I can do is this. I can put them together to make one full circle. I'm cutting out not 2 half circles, but 1 full circle. It'll be the same thing, right? With a diameter of 10 inches or a radius of 5 inches. So what I'm subtracting out here is pi times 5 squared. In other words, I'm subtracting out 78.5 inches squared, which gives me 121.5 square inches of area. Simplifies that problem greatly. Any questions? So, I'm going to give you guys a problem to work on in your notes. What we have here is a track that is 200 feet long. And 80 feet wide. This piece here is 20 feet. I want you to find the area of the track surface itself. In other words, what I'm shading in yellow here. Now it is also time for us to take our break. So what I'm going to do is we're going to take our break now. It's 10:08. And I'm going to give you an extra 5 minutes on break. So we're going to come back. We're going to start lecturing at 10:23. But the last 5 minutes of that, I want you to see if you can figure out the area of that yellow region.